Okay, this is my organ, Allen T12, I believe. So it has a full 32 pedal board and 2 full manuals. I don't have the stops hooked up yet, but here they are. So they'll make an excellent addition. The power switch is actually hooked up, but it doesn't do what it says it does. So that's on off, but the computer is actually on. So I actually made the organ into a computer. So let's take a look inside. Okay, so this is the back of the organ. This is not how it originally looked. Where the tone generator cabinet or table was right here. I just put a board on there, and so it can still slide out just like the original could, but it of course looks very different. So here's the motherboard that I used. It's a pretty cheap motherboard. I believe all of this is AMD. It's an AMD processor and board to go with it. Power supply, hard drive, just sort of screwed on here. I left the packaging material to act as sort of a buffer for any blows that it might receive and to keep it still. Okay, then here is Teensy LC connected via USB to that motherboard over there. It also has a network connection, VGA, monitor cable. This is stereo output to the speakers. We'll take a look at that after a while. So the Teensy LC has, you see these first 4 digital I/O channels, channel or pin 0, 1, 2, and 3. Looks like 3 is not very visible. There we go. It's a white, black, black, white. So they go over to this board here, and there are 6 wires, 1 for each channel selection pin. So here, maybe the back of the board is easier to see and to understand. But so there are 6 sort of buses here. Oh boy! All right, there we go. Something like that. So 4 of them are for channel selection, and 2 of them are for voltage and ground. And so one of these rows, I think this one, goes to the Teensy LC, and then this, the other 3 rows, 1, 2, 3, go to multiplexers. As you can see, there are, this row represents 2 items. One goes to a multiplexer, and the other one goes to the other board. So these boards are sort of bussed together via these wires, to the next board. And this board also supports 4 multiplexers. So you can see those here, right? There are those 4 multiplexers. This one supports 3 multiplexers and the Teensy LC board, so these are those 3. And this board has these 4 multiplexers. Now, so here we get into unused multiplexers. So these 3 multiplexers are not used at all, and this one is only partially used. You can see not all 16 channels are occupied. And then on the last board, 2 of the that sound is me pressing keys here, inadvertently as leads touch and things like that. 2 multiplexers read the 32 pedal keys. So this is an unused multiplexer way back here, another unused one here, and then the pedal keys. Oh boy, making all kinds of noise. Okay, right. So the original swell wires are up here. Maybe we can take a look. There's sort of the grid that was used to do the original sort of stop action there. And then there's a similar grid for the grate. And then the pedals, the pedal wires come in right there. So they come in a little bundle with a red wire as well. That red wire is the common cathode, and then the black wires come in here. And then I have another board, just a relay board, where I interesting. Where I bring the wire. So I just couple the wires, right? So brown ones go up, up, and then black ones go to the pedal. Hopefully that makes sense. So the brown ones go up, 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 and up here to these multiplexers that we already talked about. Okay, well I haven't wired the stops up yet, but these I think will begin the wiring of the stops. You know, it should. I haven't figured out where these go, and I might not actually have enough wires because some of the stops are actually just combinations of other stops, so it might not work quite the same when I'm ready to do it. So okay, I think that, well, yeah, right, there's one other point. Okay, so the voltage though, so there is a common cathode, and so that's what this is about. So this brown wire, you can see, is attached to the voltage bus here. The voltage bus, like I said, it goes across all, what are there, four of these boards, which is all 16 multiplexers or 15 multiplexers and Teensy LC. And then it also, I used a resistor here because, well, it wasn't working, and we can talk more about that later. But so this voltage goes up here, which is where the original common cathode was on the organ from the 50s or whatever. And then this red wire carries the common cathode down to the grate as well. And then there's another, and then of course there's a common cathode for the pedal. All right, so that's right here. So this one goes down to the pedal. Sort of see it climbing around back there. Get that light. Okay, yeah. So that, and then that red wire goes down. Yeah, so that's the common cathode for the pedal. So this all works on on Teensy LC power, and so right on here is the power converter. That little bitty black thing by the USB connector is the power. The way I know is because I've shorted it. Probably a couple times, but once I noticed that I shorted it because I was using the wrong kind of flux. I was using plumber's flux, which conducts, and so and that little unit got really hot. So that, anyway, and it sort of looks like a voltage converter, common voltage converter. So okay, I think that's about all I have to share. I mean, I guess so I can talk a little bit about the technique here. So I use these perf boards, really cheap, from China, free shipping, take forever to get here. And then I use glue, hot glue, to stabilize the joint, because if those wires move a whole lot, they can disconnect, they can rip out and just fall out, so that's no good. For the buses, I used just some wire. I stripped it all the way and then soldered it in place at each of the joints, and that forms a bus. I don't know if there's anything else to cover. Well, supplies used. All right, so this is my solder iron. So it's pretty standard. It's one of the cheaper ones on Amazon, but it's an excellent value. It has a temperature adjustment here that I don't know how accurate it is, but it certainly is different between the low setting and the high setting. So when I was desoldering a lot of these red and yellow wires, I used the hotter temperature because I was going through a whole lot of solder, and that was very effective. It came with a solder iron stand, which works fairly well, as expected. And then I just grabbed some solder from Amazon, just again, really cheap stuff. It's probably 40-60, I guess, 60-40. It says right there. And then also some flux. So I got this from Amazon, and just some rosin flux, and that helps the job go a whole lot better. I don't know if you're accustomed to using that. So okay, I think that's all I have to say here. Oh, perhaps a demonstration. So here's the screen. Yikes. There we go. Okay, so JOrgan is running here. I'm using XFCE. That's, I think, the usual desktop for XFCE. And JOrgan, that was played on the Berea choir organ. Right there. You probably recognize it if you use these very much. So, oh yeah. So there does need to be something said about the software end. So I'll write that, I guess. I'll write that up and put a link to the software that I use to scan the keys and then to send those packets to the computer and then to decode those packets of data, the key press events, and then to get them into JOrgan. And so that they register as keypresses, like so. Anyway, so that I think that about wraps it up.